In this video, we'll be talking about the big ideas in chapter 2. So I didn't, when I wrote down the big ideas, I didn't write it in the order I taught it because I put some more emphasis on some of the ideas we covered in the unit. So hopefully it'll make sense when I go over them. But I just want to mention they are not in the order which we learned them. Okay, so long division. That was the very first thing we did because it was to teach us how to divide a polynomial by another polynomial. And then we talked about a shortcut to long division, which is called synthetic division. Now be careful, there are some limitations with synthetic division. You can only use it when the factor or when the divisor is in the form of x minus k. And from long division, we also talked about quotient form and division statement. So quickly, quotient form is basically going from improper fraction to mixed fraction. And division statement is something you learned in grade 4 that allows you to check your long division. Okay, so these are both things that are very reminiscent of things you've done before. So don't think of them as entirely new. But in some real numbers, you're just working with polynomials. That's the only new thing, new element to what we're doing in this chapter. Now, we started talking about long division, but I really emphasize that the main goal of introducing long division is to help us factor polynomials of any degree, okay? Because when we introduce long division, we then talked about remainder theorem, okay? So from long division, we went to remainder theorem. We said, how can you find the remainder without doing long division? So we went through a pretty nice explanation using the division statement to explain the remainder theorem. So we now have a way of finding the remainder without doing long division. And then we ask ourselves, why would we care what the remainder is? And the answer is, because if the remainder is 0, then the divisor is a factor, which is basically what factor theorem is saying. So we can establish whether we have a factor. But in order to factor polynomials, we need some starting points, okay? So where are we guessing, or sorry, what are we guessing that are our factors for that polynomial? So luckily we have these two theorems that help us with our guessing game. So we have the integral zero theorem and the rational zero theorem, okay? So when you use one of these two theorems, you get a list of possible values that can be your zeros. And then you use them and check which one of those values are going to give you a factor. And if it was a cubic, once you guess one of the zeros, you have one of the factors. And once you have one of the factors, you can find the other two. We talked about a shortcut, which is basically finding the quadratic factor using an inspection technique. But if you're not comfortable with that, you can use long division or synthetic division. Okay, so these first 3 points, I would argue, well, specifically the second and third, is to help us factor polynomials. And if these two skill sets are not refined, if you haven't reached a decent level of mastery, then the rest is very problematic. Okay, the rest of the chapter will be very challenging. So once you're great at factoring, let's apply that skill set. Okay, let's solve polynomial equations. Okay, you can't solve a polynomial equation if you can't factor, because I will very unlikely give it to you in factored form. Okay, it's your job to put it in factor form, and then you can apply the zero product property. And then of course there are some word problems. We had a beautiful worksheet on that. So these are even harder because you have to generate the equation and then you have to solve that equation by factoring. So there's just multiple layers now. Okay, so regardless, you have to be able to factor to solve polynomial equations or solve the word problems associated with the polynomial equations. And then 5, this is actually the last thing we did in the chapter, which is solve polynomial inequalities. Okay, we highlighted the differences between solving a polynomial equation and solving a polynomial inequality. But one thing that we can agree on about solving polynomial equations and polynomial inequalities, the one thing that they have in common is the fact that you need to be able to factor. Okay, there's an extra step with solving polynomial inequalities, but to get to that extra step, you still need to factor. Okay, so if you cannot factor, you can't do 2, 3, 4, 5. So that's basically the whole chapter. Okay, So okay, 6 and 7 are the really minor details. That's why I put it at the end. So there's this thing that we learned called a family of polynomial functions. We discussed the difference between a family of polynomial functions and a member of that family. And to be honest with you, this family of polynomial functions, we did this in the first chapter. We solved for the member without using that terminology. Okay. But this idea could really be put in chapter 1. So I really won't put much emphasis on this family of polynomial functions. And sum and difference of cubes, that was just an extra bonus, you can say. Okay. Because you learned some special factoring techniques for quadratics, you might as well learn some special factoring techniques for cubics. But you know what? Like I said, these two are very minor. They're just minor details compared to the big ideas listed before that. Okay, so hopefully the second chapter isn't all that bad.